Hello ladies and gentlemen, today we're going to look at solving one-step inequalities. What you're going to want to have on you today, you're going to want to have your notebook, pen or a pencil, and then your calculator to do some simple computations. Your learning goals for this particular video: I can perform operations on one-step inequalities, which basically means adding, subtracting, multiplying, and dividing to solve for x, and I can graph the solution to an inequality. Now, let's dust off some cobwebs. Do you remember how we would have solved these problems? X plus 2 equals 6, or even 2x equals 6. Well, you're probably saying, well, Ms. Marsh, that was just recent. We're going to subtract 2. We're going to get x equals 4, divide by 2, and we'll get x equals 3. So I actually have x equals 4 and x equals 3, right? Not too hard. Now, inequalities are exactly the same thing, except you're going to have an inequality symbol in the middle. That doesn't really change much. It just kind of stays there and hangs out. So I have x minus 15 is greater than negative 12. We want to find the solution region. So I'm going to get x alone. So I'm subtracting 15, so I got to do the opposite of that, which means I'm adding 15, right? So I'll get x is greater than negative 12 plus 15, that's 3. So x is greater than 3. Graph that. So I have 2, 3, and 4. So open dot at 3 and shade to the right, right? Because 4 is greater than 3. 2 is not. What are the solutions if negative 1 is greater than or equal to y plus 12? So, let's solve for y. Right now I'm adding 12, so I've got to do the opposite of that. So instead of adding 12, we're going to subtract both sides. So negative 1 minus 12 is negative 13. Variable's not on the left, and I hate when the variable's not on the left. So let's flip-flop. I have y and a negative 13. So since I flip-flopped my y and my negative 13, my sign better flip-flop as well. So notice how it was pointing at the y, it's still got to point at the y. But my sign actually kind of flip-flopped the way it looked. Now we can graph. So I have negative 13. Ooh, hold on. Negative 13 doesn't go there. Silly, silly. Negative 13 looks like he goes here. And then let's go negative 14 over here, because he's smaller, right? And then negative 12 can go over there. What kind of dot at negative 13? Open or closed? Closed, right? So we're going to close our dot at negative 13. Negative 14 is smaller than negative 13, so on that side. Perfect. Now, here's something that you need to get into your notes 110%. Star it, highlight it, color code it, however you need, but this is very, very important. When solving inequalities, be careful when you multiply and divide. If you divide or multiply by a negative number, you must flip the inequality symbol. So if I am dividing and I see I divide by a negative, I need to turn the sign around. What does that mean? Basically, if I originally had a less than symbol, and I divide by the negative, I got to flip to a greater than. Now you're probably saying, why does that need to happen? Here's why. So I have 7 is greater than 5, right? 7 is greater than 5. That's the truth. What if I multiply by a negative 2 on both sides? I can multiply by a negative number on both sides, right? I'll get negative 14 is greater than negative 10. Hold on. Negative 14 is not greater than negative 10. Negative 10 is bigger. That's why we need to flip that sign around. Otherwise, it just ain't gonna work. So we need to always make sure we flip by it. Make sure you have a little warning light, somehow remember that you have to do this. It is gonna cause you many issues if you don't. Let's try multiplying and dividing. So I have x divided by 3 is less than negative 27. So I have x divided by 3. Get rid of that division. Multiplying. So let's multiply both sides by 3. I've gone over there. It's x. Now, didn't multiply to a negative, right? So I don't need to flip the sign. So just because there's a negative in the problem does not mean you flip that sign, okay? It's only when you multiply or divide by the negative. So negative 27 times 3 is a negative 81. So now let's graph. Negative 81, negative 82, and a negative 80 on that side. What kind of dot at negative 81? Open, right? Open dot at negative 81. And which way are we going to shade? To the left, right? Because negative 82 is smaller than negative 81. Let's do this one. Negative 3/4 W is greater than or equal to 3. So normally we would have divided, right? Negative 3/4 times W, so it's divided by negative 3/4. But that's the same as multiplying by 4 over negative 3. With me so far? Right? We've done that before. This cancels out, left with W. And, let's do some scratch work. 3 times 1 times 4, positive, over negative 3. I'm going to get 3 times 4, which is 12. 1 times negative 3, negative 4. Hold on, though. Didn't I divide by a negative? I multiplied by a negative. Since I multiplied by a negative, let's make sure that we flip our sign around. Otherwise, messed up. So, flip my sign, right? It was greater than, made it less than. Now we're in the clear. So I have negative 4, negative 5, and negative 3. Close dot at negative 4, right? Because it's less than or equal to. And then negative 5 or negative 3. Negative 3 is not smaller than negative 4. But negative 5 is. So I can shade on the left-hand side. I just really wanted left side shading problems, I guess, on this video today. Go figure. Alright. What are the solutions for 3W is greater than or equal to 3? So, looks like I gotta divide by 3 on both sides, right? Because this is 3 times W. So let's divide by 3. And I'm going to get W is greater than or equal to 1. So my start at 1, I'm going to have 0 over here and 2 over here. Close dot. Now, where are the numbers greater than 1? Is 0 greater than 1 or is 2 greater than 1? I hope 2 is greater than 1. So I'm going to shade on the right-hand side. Let's try this last problem. So, I have negative 9y is less than or equal to 63. So, divide by negative 9, right? Y, you're probably like, oh, Miss Marsh, you divided by a negative. And I'm going to be like, thank you. Almost forgot about it again. So, what would I do without you guys? I need to flip my sign. So, I got greater than or equal to, and 63 divided by negative 9 is a negative 7. So, now, let's graph. So, negative 7, negative 8, negative 6, close dot, right? At negative 7, which way do I shade? Left or right? Where are the y's greater than negative 7? This side, right? Negative 6 is bigger than negative 7. Let's look at a story problem. So, you're going to walk dogs in your neighborhood after school. For each dog you walk, you're going to earn $4.50. How many dogs do you need to walk to earn at least $75? So I know that per dog, I'm getting $4.50. So let's name that 450 times D, right? 450D. Now, you want at least 75. Does that mean you don't want more? Do you not want $100? No, you want at least, at the smallest amount, you need $75. So that means you want to be greater than or equal to 75, right? Because I want more than 75. I just don't want below 75. So let's find out how many dogs we need to walk. I'm going to divide by 4.5. And I get D is greater than or equal to 16.6 repeating dogs. Now, I can't walk 0.6 of a dog. Maybe you can. I can't. So let's round up. I need to actually walk 17 dogs. Because 0.6 of a dog, I don't know if I want to know what that looks like. So we're going to walk actually 17 dogs to get $75. And that's the end of this video. See you later, Sabers.